Hello there. I had a request to go over some of the factoring from section 13.1. So that's what I thought I would do with you today. So first of all, when we're asked to factor something, that means to express as multiplication. Express as multiplication. So for instance, if I factor 6, I would say 6 equals 2 times 3. So it's still equal to 6. We've just rewritten it in terms of multiplication. So the first type of factoring we're going to look at is factoring out the GCF. Now GCF is short for greatest common factor. So greatest common factor. So for instance, let's say I have 8 and 12. You might be asked to find the GCF of 8 and 12. So factor, in this case as a noun, is going to be something that divides into something. So the greatest common factor of 8 and 12 means the largest factor they have in common. Well, in other words, what is the biggest number that goes into both of these evenly? And that in this case would be 4. Now, let's take a look at the variables. If I have x cubed and x squared, and we want to find the GCF. Well, let's think about that. If I have x cubed, that means x times x times x. If I have x squared, that means x times x. So the greatest common factor is going to be the most number of x's that they both share, if that makes sense. So if we start pairing them up, we run out, right? They only have 2 in common. So the most number of x's they both have in common is 2. So the GCF is x squared. So a little shortcut for variables is this. The GCF of variables is always the smallest exponent. The GCF of variables is always the smallest exponent. So for instance, let's look at another example. Let's say I have 6a to the third b, and let's see, 8ab to the fourth. Let's make that a to the fourth also. And the directions say find the GCF. So the first thing you do is look for what 6 and 8 have in common. What's the greatest factor of 6 and 8? And that would be 2. 2 goes into 6 and 8. Now take the variables one at a time. If I have a cubed and a to the fourth, the most a's they have in common is the smallest exponent, which is a cubed. And then if I have b to the first and b to the fourth, again, this is an understood one, then the most they would have in common is b. So that is the GCF. So the first part of this assignment, and you may already have attempted it, the first part of this assignment is just finding the GCF. Now the next thing you'll be asked to do is actually factor out the GCF. So I think I wrote that down a minute ago, but now we're actually going to do it. So the directions will say factor. And we'll start with an easy one. So factor 2x plus 10. So what we want to do is identify the greatest common factor of 2 and 10, and that would be 2. So you start with the GCF. Now I'm going to open a parenthesis, and we're going to do the distributive property backwards. So in other words, 2 times what would equal 2x? And of course that needs to be x. So 2 times x is 2x. Now 2 times what do I need to write here so that when I multiply it by 2, I get 10? And that would be a positive 5. So what I have here then is a factorization of 2x plus 10. I've taken 2x plus 10 and rewritten it as a multiplication. Now I have 2 times x plus 5. And again, you can check it by doing the distributive properties. You can always check these by multiplying them and being sure you get what you started with. Okay, let's try 25a to the 4th plus 15a to the 6th. So again, the directions are going to say factor. So let's see. What do both of these have in common? In other words, the biggest number that divides into 15 and 25 is 5. But we also have a to the 4th and a to the 6th. So the greatest common factor for variables, the most number of a's they have in common, is the smallest exponent. So this is going to be a to the 4th. So this is my GCF. We're going to open a parenthesis now and start the factoring. So 5 times what is 25? And that would be a 5. Now, do I need to multiply by any more a's to get a to the 4th? No. So 5a to the 4th times 5 is 25a to the 4th. Now we go on to the next one. 5 times 3 would give us the 15, and a to the 4th times what would give us a to the 6th? So we might do a little side note here and refresh your memory for something called the product power. I'm sorry, the product property, which tells us if I have x to the m times x to the n. In other words, when you multiply variables with the same base, you keep the base and add those exponents. So in other words, if I had x squared times x to the 5th, that would be x to the 2 plus 5, which is 7. Now, why do I need to know that? Well, for this problem, I have a to the 4th. I need to know how many powers of a I need to multiply by to equal a to the 6th. So we need to recognize that that means I'm adding those. So you're really saying 4 plus what would equal 6? And that would be a 2. So to check it, when you multiply, 5 times 3 is 15, a to the 4th times a squared is a to the 6th. So we know that we did it correctly. Okay, so let's try another one. Let's say 36x squared minus 12x to the 5th plus 6x to the 7th. Excuse me. So the directions will say factor. And we know the first thing we need to do is find the GCF. So the GCF of 36, 12, and 6, the biggest number that goes into all of them evenly is 6. Now 3 goes into all of them as well, but 6 is the greatest common factor. So we're going to use 6. And then if I have x squared, x to the 5th, and x to the 7th, we always pick the smallest exponent. That's the most they all have in common. Now we're going to open our parentheses and think about the distributive property in reverse. So 6 times 6 is 36. We don't need any more x's. Go on to the next one. 6 times negative 2 gives us the negative 12. Now x squared times how many powers of x would be x to the 5th? We know we need to add them, so that would be a 3. And then plus 6 times 1 is 6. We don't need to show the 1 there. But x to the 2nd times x to the 5th would give us 6x to the 7th. So that's going to be our answer. I need a cough button. All right, so let's do one more of these. Let's say 5x plus 5. Okay, so kind of a short one. The GCF, of course, is just 5. Open our parentheses. 5 times x is 5x. Now 5 times what is positive 5? Now you might say, well, we don't need anything there, and you close your parentheses. But when I multiply this, does it give me what I started with? No. So you have to put a 1 there for a placeholder. Now you might be saying, well, wait a minute, you just said we didn't need to write that. So let me pull this back up. So what I said, in this case, we didn't need to show the 1, for 6 times 1 is 6, because I knew I was going to have some x's there to hold the place of that value. Here, when there's no variables or anything else there, you have to show the 1 in order for your problem to check. So I'm going to stop this installment here and let you go practice these if you need to. And I'll put one up for the second part of this chapter, which is factoring by grouping. So we'll say factor by grouping coming next. All right. So we'll see you then.